Welcome to Saitechinfo channel, my dear students. In today's session, we will be discussing about the overall aspects, that is the summary, or you can call it the sketch note of limits and derivatives. Let me see one by one. First, we will discuss limit. The limit, it is represented, as I already mentioned in my earlier classes, as lim or limit. Then you have to put the f of x, the function. Then x tends to some fixed number. So we can, that is, branch out as three major aspects. And before that, you should understand that if the limit exists, left hand side limit should be equal to the right hand side limit. Now, let us look at some standard limits. And we need to discuss about the properties of limit. Then we should know something about L'Hospital rule. Let us see one by one. Limit where the x tends to infinity for 1 by x function. You know, by substituting lambda and not lambda, that is infinity, in x, you will get 0. So 1 by infinity, anything by infinity becomes 0. Then limit x tends to 0 for the function modulus of x power n. That is also 0 where n is greater than 0. Where n is greater than 0. Then third one, limit x tends to 0 for sin x by x. This is always equal to 1. Then, and we have an explanation in the next classes for each standard limits. Then limit e power x minus 1 by x. E power x minus 1, e power x divided by x for x approaches 0. It is always equal to 1. Okay? Have you noted down? Right. Now let me proceed with the fifth point, sorry. Sixth one, limit x tends to infinity for the function 1 plus 1 by x whole power x is given as e. Then 7, limit x approaches 0 for the function 1 plus ax whole power 1 by x is given as e power x. But it's not e power x, should be e power a. Then limit x tends to 0 for the function log 1 plus x to the base e. So this can also be represented as natural log 1 plus x. So when you put ln natural log, you need not put e. Okay? So this is equal to log 1 plus x to the base e. Right? Okay. Now let me proceed. Divided by x. So for which the value is 1. In fact, we have to find out, we have to derive the values, but before that, I would like to that is explore the standard limits of some important values. Have you noted down? Then 9. Limit x tends to infinity for which the function is 1 plus a by x whole power x. A by x whole power x is given by the value e power a. E power a. Okay? Right. Let us proceed further. Have you noted down? Okay. You can as and when required, pause the video and note down all these points. And then 10th one. Limit x tends to 0 for the function a power x minus 1 divided by x. So the value for this is natural log a. It means log a to the base e. Okay. Next, limit x tends to 0 for tan x by x, for the function tan x by x. that is given as 1. Then limit x tends to, let me say, a, where x power n minus a power n divided by x minus a is equal to n a power n minus 1. n into a power n minus 1. Then yes, let us continue. So limit x tends to a for the function x power n minus a power n divided by x minus a is equal to n into a power n minus 1. Now let us proceed with the 13th one. Limit x approaches infinity for x power n, that is equal to 0, provided modulus of x is less than 1. Then limit x tends to 0 for which the function is 1 by modulus of x. The value is given as infinity.